Hello and welcome everybody to this webinar about lifetime risk and unfavorable examples. My name is George Neureiter, Market Manager Renewable Energies at Hellermann Titan. In this webinar, you're going to see a lot of situations that you might seen in the field, and we're going to propose you some remedies. Let's have a closer look about the lifetime risk of a solar plant. This is showing you the operation of a solar plant from the year 1 up to year 25. The curve, the power curve, which is displaying the yielded energy, starts at zero, and at the very end you will have a certain generated amount of power. This should be ideally linear, but this one is a little bit curved because of some degradation processes going on the solar plant, which is pretty normal. But that could happen a lot more, which you have never been planned for. The first thing could be that for some reason you're occurring performance losses you've never been planned for. So it means that you got suddenly stress on connectors, the resistance of the connector is increasing, you might have suddenly connector and submerged in water you never planned for, you might have bifacial shading because of the cables have not been put out in a proper way and shading the backside of the solar module. You could have some bundling issues in terms of coils, also adding to loss of energy. So this has not been planned for. And on the right top corner you can see you have a little bit of lost energy due to this occurrence. So during the course of operating your plant after year 9, you're suddenly also having issues with environmental aging. Cable ties not being planned for, they're falling off because of the wrong material. Maybe you have chosen a very cheap cable tie that's falling off. You could have zinc chloride issues because of the plant located close to the sea, and in combination with the salt in the water and also rain, you could have zinc chloride on coated zinc steel structures that causing any plastic material actually to degrade. There are remedies to that, so just choose the right material. So that causes also loss of energy. So if we further move on, you might also see inverter downtimes because of grounding and earthing faults. Maybe the sheet of your cables are destroyed by rubbing or sharp edges, and therefore you have to replace that. It means downtime of your plant, adding again a loss of energy. And moving further on, you might also face unplanned maintenance that has not been planned for, like you have water in your solar combiner boxes, you might have cable ducts buried in the ground, and they are full of water and the cables are degrading, has not been planned for. Maybe even lost identification because they are not readable after 10 years of operation of this plant. And finally, if you don't take care in a proper way, you can even have a fire on your plant. If this is a commercial grade rooftop installation, you're facing serious issues. So please make sure include proper cable management to avoid all these issues, and also to keep this kind of curve at its maximum performance. It can all be avoided by a proper selection of cable management products. So having talked about the risk, let's have a closer look about specific pictures taken from the field. One of my favorites is actually this kind of cable tie used through the mounting hole of a solar module frame. This is pretty commonly used, so you see that a lot on the field. It's very cheap, of course, but there are some points I would like to point out. The hole in this solar frame is laser cut, which means it is razor sharp. It will cut into the cable tie. Let me demonstrate how that is working. Got the simulation of a solar mounting hole. I've got a cable tie over there. So this cable tie is moving slightly over the course of operation, and it will gradually cut into this kind of material. It doesn't matter what kind of cable tie you're using, it will cut over time into the cable tie. And the second issue is it is angled at the 45 degrees. So if we have Let's take this cable as an example. If we use this in this kind of setup, you can see the cable tie is angled 45 degrees over the cables, which is not the design a cable tie has been designed for. Let me explain it a little bit in a better way. A cable tie should be 90 degrees to the direction of the cables. This is the application of a cable tie it has been designed for. Anything else like this here should be avoided. All right? We also have the issue that the cable tie actually is pushing this kind of cables onto a metallic edge, which should also be avoided. So the solution to this is actually to avoid that and use proper cable management solutions. Hellermann Titan offers a wide range of that. One of it is edge clip, metal solar clip, push button mount, LOC series. We've got a lot of solutions that we can offer you to overcome this issue. The second picture is actually no cable management on a fixed tilt installation. So that is working for a while, but I would say in a couple of years this plant is going offline for sure. It means to have a constant pulling weight on the junction box, which is not good. If this is located in a northern hemisphere where you have maybe also ice and snow, it can even add to the load of the cables onto the junction box, and that is also going to fail. You could even have water accumulating at the bottom of this connection because the water drops are flowing down and then accumulating at the connectors, and the connectors is exposed to the water all the time. Of course, any wind is adding problems to these issues, and you cannot do any undergrowth maintenance, neither with sheaves or neither with moving equipment, because the cables are in your way. You need to deploy a proper cable management there. That's the recommendation. Let's have a look at this one. This is a floating solar power plant where the connectors emerged in water. That's not a good idea actually, because the connector has never been designed to be used for this application. So that's going to fail on the long run, definitely. It could be also exposed to the wave movements. So even if the connector is not touching the water, there can be waves due to wind or both movements, and that is also exposing the connector to water. The water can freeze over, and that means if you have shifting ice, that is going to tear off the connection definitely. And you are also facing danger of biofouling. So you can have mussels or algae accumulation on your connection, which you don't have been planned for. So the recommendation there is deploy a proper cable management to avoid this issue. This example is a tracker installation that has been put into the desert, and after 2 years using a metal tie, the coat of it came off. That means that the sharp edges of this metal tie is exposed and rubbing into the cables. So the tracker movement actually is adding to this issue because you have a lot of dynamics involved now in this situation. That can be avoided either by using a polymer solution which is high UV resistant that overcomes this issue, definitely. This picture here shows you what happens when the load on cables has been too high. There has not been used any arrest points, so once the first connection failed, the load of the cables is adding to the load, and like a zipper, all of them are falling down over the length of the cable. The load is too high, so there should be a proper engineering to make sure, or fixing points, that this cable are not falling off. If we are facing here a tracker installation, the dynamics should not be underestimated. The solution actually is to implement proper arrest points. What an arrest point is, I'm explaining in a different webinar about fixed tilt, tracker, agrivoltaic and rooftop installations. UV degradation, of course, is a common issue in solar plants. This picture shows you fallen off cable ties after 4 years exposed in a Nevada desert on a tracker installation. It has been, in this setup, the wrong material has been used. It should have been a different one. Could be polyamide 11, for example, as a proposal that is much better situated for this kind of installation. To always take care that elevated temperatures are also weakening plastic materials. So choose the right material to overcome this kind of thing. Also, humidity is highly underestimated. Very dry areas and also very humid areas are also impacting the properties of the material. There's another webinar where I'm going to talk about the material properties and the influence on that one. And also take care about the movement of the tracker. You have a dynamic load that is adding stress to each fixing points. So the proposal to overcome that is use the proper engineered cable management solution. That's also a favorite from myself. Do not take care about the corrosion of the substructure. It's all about sharp edges. So those kind of cables are definitely going to be damaged due to the exposure to sharp edges. The failure is imminent, so this plant is going offline very soon. Avoid shortcuts and grounding faults by implementing proper cable management measurements. Also take care about not implementing edge protections because they also can fail. So make sure this is going to work. This is an example about undercutting the minimum bending radius. On this picture you can see that the pull of the cables are too high. This connection with the junction box and the bending radius is going to have to cause failure of this operation of this plant. So the cables will be damaged because also of the thermocycling. The whole plant is expanding over the day and shrinking over the night. Also take care about this one. You want to avoid also shortcuts and grounding faults when there are sharp edges exposed, like at the bottom of the picture you can see. So the recommendation there is actually to avoid any stress of the cable by implementing a proper cable management. Also check the model orientation, the length of the junction leads, just to make sure all of this is working on your plant setup. So concluding this, about what are the takeaways of this 2 sections I have been mentioned here in this webinar. The first one is lifetime risk. Usually it starts with small issues. You don't see it. You don't see the outcome first when the plant is still supplying energy. But if you don't take care, a lot of energy can be lost because of not taking the correct measurements and replacing the parts. Make sure also to deploy the proper parts that last for a very long time. There are 2 more webinars explaining what kind of parts, for example, can be used from Hellermann Titan. So avoid any unnecessary risk by deploying the right engineered solutions. Avoid any risk by also taking care about how the cables are managed in a proper way. And to sum up the unfavorable installations, there are some parts that are misled or misused for its application. Make sure that you use only parts that has been designed specifically for this purpose. If you ignore any cable management as a final word, the plant is going to fail. Make sure to implement a proper cable management. Make sure the connectors are not touching water in any case. Make sure the sun is not touching the connector in any case. Make sure that this all is going to work out. And then you have very low operation cost over the operation of your plant. Hellermann Titan is your right partner to offer you a wide range of product solutions to overcome this kind of issues I've mentioned before. So thank you very much for joining into this webinar. My name is George Neureuther. Let's stay in contact. Thank you very much.